So there was a prompt last time on a request that we look at December 2024. We were to look at December 2024. I think it was question 3B. We can look at it, but I suspect that maybe the main question the member wanted us to look at was, I think, part D from my analysis. Part D we have not yet covered. If that is what was worrying me, I hope she's here. This one requires another concept. There's something called a confidence interval. Kuna topic to cover when we will be discussing something called test of hypothesis. Then it is where confidence intervals arises, that once you have a mean value, the concept will simply be a mean value cannot be 100% accurate. It needs to be adjusted for some errors where the sample might not be accurate. So kuna kitu tutaita Z that you require. We have not yet covered. Alafu you multiply with something to sampling error. We'll be calling something sampling error. So a confidence interval is this. Lakini yearly combine the topic that you have already covered with a future topic that is done. So hii part ya pili requires some patience until we get there. So my request to the member, because I'm sure expected mean, we agreed we just work with the probabilities. So I'll do part 1, 2, and 3. Alafu part 4, unless we will have to wait. We'll have to wait until we get to this part, unless you just want me to fill things that might end up confusing you. In future, you'll be able to handle it based on what I'm rubbing now. But the rest you should not worry. Part 1, we agreed kama uko na probability like this. Now let's just do part 1, 2, and 3 very fast. We'll patia the answers in case that is also what she wanted. We know that expected mean of the random sample is just the expected sales. So convert this thing into mid-x. So equal 50, equal 150, seeing to 50, 350, 450, 550, 650, 750. Then the expected mean, kama uko na probability, hii mtu ashakudividea by the number of items. So what you will do is you just multiply the summation of this mid-x by the probability is the expected mean. We agreed, don't divide again. E total add must be 1. So since it has already worked, it has already divided by the number of items, you do not again have to divide. So you can multiply 0.2 times 50, like that one looks like, I think 10. The first one, appeal, E total XP. Maybe somebody to just give us, we have time as we wait, even I'm seeing the numbers are still low, to only 11 of you here. So those that are here, as we can burn some 5 minutes. Nitafutie total. What is the answer for the first one? I've started you off. 0.2 times 50 is 10. Nieke ingine. Or if you have done it, you can just tell us the answer. What anybody with this total that I am filling here, that will be the expected mean.
281.
381.
281.
281, thank you. So somebody has done it, asante sana. Weka tu hiyo 281 hapo, na you also come and say the answer is 281. Expected standard deviation. The formula for standard deviation, we know tulisema it is kama kuna, if you're dealing with probability, just subtract every value with that mean of 281, square it, alafu find a way of multiplying with p somewhere without dividing by n. So what will you do? You can just put that column here again, x minus by x squared answer ile unapata you multiply by p. P inaweza kuja mbele ama nyuma, doesn't matter. So like the first one, you should be doing 50 minus 281. Square that answer, and for averaging, you multiply by 0.2. Just what the bracket is saying. Solve the bracket first and then multiply with the probability. So 50 minus 281, square it, times 0.2, you put something there. Okay? Hii inaitwa variance. The sum that you will get here is called variance. If you square root it, itakuwa standard deviation. Anybody with this total again? Anybody with this total? Deviation squared. If you average them, averaging something is either multiplied with the proportions or divided by the number of items. But now we have the probability, we don't need the proportion.
35 on 39.
35 on 39. Standard deviation will be the square root of that. The standard deviation here will be the square root of 35 on 39. What is the square root of that answer? Thank you very much for having given it an attempt. Square root?
187.45.
187.45. So those who didn't attempt it, look for it. Alafu hii ingine ni it's just a percentage. We want a coefficient of variation is that standard deviation divided by mean times 100. So it will be 187.5 divided by 281 times 100. It gives you the element of risk associated with this expected sales of yours. Now that these are sales, zinaweza enda up or down. 187.5 divided by 281, this looks like quite a high. It's more than 50, because more than 50 now, that is high. 66.71%. And if those who are still joining, you for Roman 4, this one will be revisited. I'll remember to come back to this question and we look at it. Hiyo kitu inaitwa confidence interval. Kuna some discussion that we are yet to cover. So allow me not to discuss it now so that tuache tu up to where what we have covered. But tukishamalizana na syllabus, Roman 4 will be doable for you. It's just a range. You should be able to give a confidence where you can say, even if this mean is not 187, it's not 281, I am willing to say with this level of confidence that it can be between this and that. Kuna margin of error that is always associated with samples. So umechukua tu 150 invoices, alafu unakuja unasema average sales ni hii. So you should be able to tell somebody what error is associated with it. You're in a discussion in your future today, cover bad. So I hope she's here, the lady that I'm really doing this for. Then in future, I will revisit it. Any other question? You, I think, covered nicely. We discussed probability. Probability in a proportion, kipewa. Change to frequency to probability. Lakini sama ulikuwa divide by summation of f. Wachana naye, because summation of probabilities is 1. So hata ukidivide na summation of probability, you'll be doing nothing. Any other question before we introduce something else? Kuna maswali tulipeana tukasema end hata beyond mimi mpaka 2021 when the syllabus was reviewed in December 2021. That is when hii topic ilikuwa introduce. Usiende beyond 2021 utapata swali huko Ziko tu from December pilot paper na hiyo the real exam ya December 2021 onwards mpaka saa hii hakuna sitting utachukua ukose swali ya mean, median, mode, standard deviation, quartile deviations, skewness. Give them now the justice they required, even kurtosis kama iko do that ni formulas maliko na formulas. By the way, I don't really expect a lot of tasks because once uko na hiyo formula, the rest tu sasa ni processes that are almost mechanical. But kama kuna swali, I'm still pausing before I take you to the next discussion. Kama kuna swali uko nayo, usisuffer in silence. We are here for ensuring tuna move pamoja. Vero, do you have any question? Is it making sense, these things that we are discussing so far? Are you okay? I'm just collecting a sample to see that topic imeisha. I'm looking for validation to move to the next topic. Vero, you want to tell me, just say yes, whether to move on ama kama kuna swali? Ezra, are we okay?
Yeah.
Okay, Vero, as I've seen your comment, thank you very much. Ametuambia go green light to move on, thank you. One more person, just to be sure. Otieno, Christine Otieno, can we go on? Otieno, Christine, is there anything that you want us to discuss before we proceed? Okay, assuming silence means consent, so we can proceed. Correlation and regression is the next discussion that we can introduce now and we finish it next week. Correlation and regression. Another very important area. I'm trying to start with critical areas where, and I'm saying by now, at your exam, if you have been following, you should just be able to pass 7 questions and you're just supposed to do 5. Hata sahi huwezi kosa 4 questions in any sitting, which you do comfortably. You don't need all the questions to pass. Exam pass mark me 50%. So already we are in good form, but I'm starting to, I've always been covering areas that are critical. So in QA, everything is critical. Anything can be tested. So ignore any area, but you will just be required to do 5 out of 7. Sijaiona mtu ule ako serious anapata shida na QA. So be checking the past papers. So far unajiuliza how far can I go? Chukua 20 sitting anytime uko peke yako, jiulize so far are there at least 3 questions that I can comfortably do by now. Usikose, you should be able to find 3 questions that unafanya to comfortably and you are happy. I'm adding you another one, which is very, 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 very common, almost always appearing. You can also use it to leverage on passing the exam. So correlation and regression. That in correlation and regression here, we want to say that once data may collect, you might collect data for a set of items, usually called X and Y. Anything, if you collect 2 X and Y, you might always in statistics wonder whether these 2 things are in a relationship or not. For purposes of predicting, you might always want to look at one variable, utake kujua, could there be a variable that can help me in determining its value. Why? Suppose uko na why, unaweza kuwa kuna kitu inakusumbua. Maybe you are looking at your maize harvest. You have been collecting your maize harvest. Sometimes unapata 10 bags, sometimes unapata 15 bags. So as somebody who knows statistics, unataka kujua, are there some things which might be influencing the number of maize harvest that I'm getting? So maize ikikuwa y, itakuwa your dependent variable. What are some of the factors which might be making my maize harvest to be high? Okay, so any variable that utataka kuchukua, unaweza taka maybe kusema rainfall. Rainfall. You might also want to look at rainfall that averagely was recorded in that whole period when you're planting and your harvest. So that ukusema hii rainfall ikifikanga this much, watu wa meteorological mfano wakisema hii 6 months, we are expecting wakiweza tuambia the amount, the quantity of rainfall, they usually have ways of measuring it. Then niangalie my maize harvest, I might now want to see, is there any correlation between your rainfall na nini na the maize harvest. In business, you might want to look at also your variables. Business variables zinaweza kuwa kitu kama sales. Hata hiyo example tumefanya sasa hii, tumeona ilikuwa na inaangalia sales that have been harvested under their probabilities. Unaweza kusema hii sales napata every time nikiita y. Is there anything that could be an x which determines the amount of sales? So unaweza sema maybe price ya kila product. Maybe niki increase price, kuna vile sales inakuwa affected in terms of quantity or even in terms of money. So you might want now to tell somebody that there's a correlation between X and Y. In statistics, or when we now want to really apply statistics, we always want to understand how variables are connected with each other in terms of, is there any correlation? And tukishaona kuna correlation, tunaweza enda further tujiulize, which one is really causing the other? Okay? So if I just give you at X and Y, it doesn't matter the order. Correlation will just be a question when one variable changes. Kwa hizo mbili umechukua, am I observing that the other one is also changing? The moment a movement in one variable is associated with a movement in another, then we say there is a correlation. English to hata schedule ina sound. Correlate. It is the first step in understanding behavior between variables. We just check hata by na macho tu ama from past experience. Unaweza tu kusema, I've observed in the past that every time I have more money, my expenditure on luxurious items ina increase. Na zile sina pesa na kanga tu kwa nyumba, I don't even live. Hiyo ni correlation. So ukipata pesa, your tendency to go and spend it ina increase. Correlation is there between money and your expenditure. Income and your expenditure. You might also observe that there is a correlation between the amount of study hours I put on my classes, the attention I give every semester to the units that I'm studying, and the grade that I will get. Zile semesters umepatia more hours of study, unapata grades mzuri. Ile semester umekuwa uko busy na job na other things, ma distractions, unapata grades zako zinashuka chini. Correlation, you might want to always tell us about that. Once tumeshajua things are correlated, nikijua that maybe the price that I'm charging the product determine the quantity demanded, correlation is there. The next thing would be to capture that correlation into a model that can be used to predict one given the other. Okay? So nikijua kuna correlation, nimesema tu ni movement. Una observe tu unaona hii ki increase maybe inashuka. Okay? That is correlation. Naweza angalia tu time na population. Ni notice that as time goes, population ina increase. Correlation is just telling us hii ki move, hii ina move. Hata ituambii gani ndio inakosa ingine. Unaweza hata sema population na time. Population iki increase, most likely time pia increase. Hiyo ni correlation. But now in regression, we will want to quantify that correlation into a model, maybe an equation, which we can use to predict even the value of one provided tuko na value ya ingine. So the moment tunaanza kuangalia the way these two things are related, so that if population now needs x na population needs y, I might want to say something like y is equals to a plus bx, so that hiyo population ndio y, a ikwe ile value tutakuwa tunaongezea, alafu bx ni the rate at which time, kama ni t, ina create this population. So if I have a, maybe a equal 10, then ukinipatia t, I can be able to give you population. So to regression inakuja next, itakuwa a way in which to regress is to go back and find an average relationship. So ukitupatia the average way in which one variable is influenced by the other, so that I can predict. It is for prediction purposes. Ukinipatia model that can be used to tell me the value of one variable, bora umenipatia the variable ingine, we will be calling that next week regression. But for today, and maybe even part of next class in class on Tuesday we'll meet in class. We will want to introduce to you into what correlation is, and then Tuesday na Wednesday tumalizane nayo, uende kwa past papers. Put this down. It's just that in English, to correlation pattern in movements. Regression is a forecasting tool. Say, in statistics, variables will be studied. Variables will be studied with a view to establish relationships amongst them, for purposes of understanding their behavior, and other important functions, such as planning, decision making, and control. We may want to be convinced that two or more variables are connected. Two or more variables are connected, and then quantify this connection, into a model that can be used to predict. The value of one variable, given the value of the other. So start it off. Number one, subheading, your connection inakuwa determined through correlation analysis. So say number one, correlation. This is the existence of a definite relationship, in movement. A definite relationship in movement between variables. in movement between variables. Between variables. If two variables, move in the same direction, that is an increase in one is accompanied by an increase in the other, this is known as, underline it or highlight it, positive correlation. This is known as positive correlation. Positive correlation. Example, there is a positive correlation. There is a positive correlation between time and population of a country. Though nowadays, some countries na suffer, time in increase, their population is going down, because people are not marrying, others are marrying from the same sexes, so populations are going to reduce. But then if things are just normal, then you would expect that as time goes, or over the last years we have been observing, population in the world increase from very low levels. At Nairobi, before, we were very few. Nowadays, to congested, people are running away into outside. But anyway, time can increase. Ukiona time in increase, population in increase, tuambie kuna positive correlation. Maybe another one, or a positive correlation may exist. A positive correlation may exist between the quantity of rainfall, and rice harvests. You can put it as the next point. If two variables move in opposite directions, this is negative correlation. This is negative correlation. That is an increase in one variable, accompanied by a decrease in the other. Example, a negative correlation may exist. Between price and quantity demanded, price and quantity demanded of a firm's products. Price and quantity demanded of a firm's products. Price and quantity demanded of a firm's products. So that is a negative correlation. We are saying if you observe that when you increase one variable, the other one is decreasing, then talk of negative. But if they are increasing, they're moving in the same direction, in the sense that you increase one, the other one also increases, then you can talk of negative. There can also be no correlation if there's no pattern. If you can see that sometimes in an increase, the other one in an increase, in an increase, in a reduce, sometimes they are all just playing all over the space. That is no correlation. There can also be nonsensical correlation. Nonsensical correlation is that one which it may happen just by chance. It appears spurious. Spurious, maybe we can talk about it as a kuuliza. A spurious correlation it makes sense. It may happen, lakini once you interrogate it from past experience or from a judgmental point of view as a human being, unafeel ni kama there is no real relationship, then we talk of it being spurious. Ni kitu haiwezi hold. Leo imefanyika na kisha ukiangalia you find that tena ija happen. So it only happened by chance. You can dismiss it. Like for example, today I might send you to a road to observe the kind of people who are driving white cars. You might want to study, is there a correlation between people driving white cars and maybe their height? So today unaweza enda pale kwa barabara useme, I have noticed that today all or almost all white cars that are passing are being driven by maybe short people. That's fine. That's what you have observed today. Yes, you can conclude that there's a correlation between short people and white cars. But then ukienda huko the next morning uende ufanye the same research, you might find in reverse. The second day unaweza pata it is tall people who are driving the white cars. Therefore, hii ndio inaitwa nonsensical or spurious a correlation that cannot stand the test of time. It only happened due to chance and it cannot hold. Maybe explain it, Nisha. I think I've seen it. I've seen somebody asking me that question somewhere. In theory, just say, spurious correlation, spurious correlation or nonsense correlation is one which has been observed but cannot stand the test of time. Has been observed and cannot stand the test of time. It is a chance correlation. It is a chance correlation. Then put a subheading. How do we measure? The most important part that we want to dwell on is what models can we adopt that can be used in checking for this positive or negative or no correlation that there might be between two variables that you're observing. So say methods of measuring correlation. Methods of measuring correlation. Number one, the most common, the easiest method one is apply, call it scatter. just draw a graph. This is the simplest method. Chora two graph here, your x and your y. Whatever variable you want to call x, put it on the x-axis. Come any time, let it be on the x-axis. If you're studying population, put population on the y-axis. Then what do? Plot. This year, what was the time? They call it time 1, population, plot it on the y-axis. Year 2, check the population, plot it. Then you check the kind of pattern that is being developed. If it is an upward trend, you can say it is positive. If it's a downward trend, you can say it is negative. If it is constant or if there's no correlation, then that is also something you can observe and tell us. Just put that down here, and it's the easiest method. Say, this is the simplest device. This is the simplest device. This is the simplest device of testing. Of testing. Of testing for the presence. Of testing for the presence and degree of correlation. For the presence and degree of correlation. Data is simply plotted on a graph. Data is simply plotted on a graph. Simply plotted on a graph. With a view of observing the scatter. The view of observing the scatter. And conclusions made. And conclusions made. And conclusions made based on personal judgment. Based on personal judgment. That is, so draw some small diagrams too. Suppose I was observing anything, X and Y. Alafu, I observe that the data is almost on a perfect line. Can even get a straight line out of it. Then, if they are running up like that, in Maisha X increase, you can see Y is increasing. Your comment, if I gave you a set of data X and Y, and you plotted them, upate kitu kama hii tuambie tu now, your comment here will be that there is perfect, positive correlation. That is what you can tell us is perfect positive correlation. If we plot and you get the other way around, your observations are dropping down. Yes, that is also perfect, but you're negative. So X and Y, if they are behaving like this, there is perfect negative correlation. Perfect negative correlation. If you plotted them, alafu scatter ikaanza kukua, they are not on a perfect line, lakini unapata feeling as if they are tight, ziko close, hata kama sio straight line perfectly, zina form like hata ukichora line katikati yao inakuwa a best fit, vitu ziko very close to each other, then hii tuambie tu you are seeing a high degree of positive correlation. High degree of positive correlation. Vice versa is true. You keep plot and you get a feeling zinaenda chini but very close to each other. Not on a straight line, but very close. So just reverse useme tena. You're seeing a high degree of negative correlation. You could plot, na sasa hiyo scatter ikwe wide, But one of the main problems with this method is that whatever you think is positive, especially hizi low, mwingine anaweza feel mwingine anaweza feel ni negative, but by sasa increase to space, space, but so that ikae kama upate feeling ni kama zina increase. If you feel you can see in the problem, usiandike, don't draw these lines, huu unaona ni kama sa generally zinaenda huku, but mtu mwingine anasema pana hizi tu zilianzia huku zinaenda huku, so that is where now the problem is with the ones that are low. One of the the main problem tutaandika with this method is that it is very subjective, what you might view as if it is a positive, mwingine anaweza, lakini ukispread scatter ikikuwa wide, just widen E high, this one that is high, just widen it so that it can come as dispersed with a few items, so that tuweze kusema that tunaona a low degree of positive low degree, aziko kwa straight line na ziko scattered, then almost do something as almost the same diagram, but draw it so that feeling yako ikae kama sasa zinaenda zikishuka, okay? It's almost the same diagram if you look at it nicely, but then kama wewe sasa utakuwa na feel hapana hizi vitu zinatoka huku zikienda huku chini, huku ndo zinaenda, then tuambie tu now as you increase x there's a small tendency or there's a small chance that as you increase x, y is decreasing. So low degree of negative correlation. Very subjective. Hiyo ndio weakness, different people might categorize, might come up with different classifications of those costs. If you plot and then x's equal all over the place, hakuna pattern, draw as many x's as you can. Hizi vitu zote weka xy, xy. So I'm saying if you plot your x and your y, alafu x's ziko all over the place. Just say hauoni pattern, so there's no correlation. X and y are not related. Leo x inaweza kuwa hapa, y iko hapa, next time x iko hapa, ikiwa hapa tena imerudi pale, no correlation. But though it's usually the first step, if you want to capture a rough idea of the correlation that there is, we usually start with the graph. Alafu sasa sisi ni statisticians na numbers, So better methods are there that this analysis can be done in terms of figures so that numbers zituambie tu speak for itself. Kama ni high, kuna watu wamejaribu kutupatia formulas wakina Carl Pearson. I told you of somebody nilikwambia utaishi naye for a long period of time in statistics called Pearson. He has given so many formulas. So the next one we want to look at, Carl Pearson atatupatia formulas that can tell us whether we have got a positive correlation or not, and how high it is. So say, though this is the simplest method, its main limitation is that it is highly subjective. That is different analysts may draw different conclusions from the same data. It is, however, usually the first step in checking for the nature of correlation. Then bring in Carl Pearson. Carl Pearson comes and says, why don't I just give you a formula that can play around with standard deviations and your data you angalie where the line of best fit can be and how fit it is in terms of, is it perfect, positive correlation or negative, formula to which interpret here to the chap and you are done with your problem. So Carl Pearson's correlation coefficient say Carl Pearson has provided a formula which can be used to test for the presence, nature, and degree of correlation. So what does he say? Andika formula before that, and Rudico formula, we will be denoting it with small r. Andika hapo bracket small r. But other before nikupatie formula r is the symbol for Carl Pearson. Wengine utapata wanakupatia capital R. But because kuna two people, kuna Carl Pearson, kuna mwingine watatu pia atatupatia R yake. So kuwa differentiate tunataka R small equal Carl Pearson, alafu capital R equal the person we will discuss after Carl Pearson. So before that, even in fact say, he named Jinela alipatia yake. You can also be asked to get it. Alipatia jina lakini some people came to like it. Nowadays we usually just call a formula. Hata ukikuja na invention, it might end up being given your name. That is a common practice in statistics, mathematics, and sciences. But then alipatia jina. So put the name he gave it. So say he named it product, moment, kuna kitu inaitwa statistic moments, you don't need it. Product moment correlation coefficient. So hata swali ikikwambia find the product moment correlation coefficient, think of Carl Pearson. Let's just make sure you appreciate that. So put the formula R according to him. Carl Pearson anasema ukitaka kupata R, tumia this formula: N summation of X Y minus summation of X summation of Y all over, put a big square root under that value, and then he says do N summation of X squared minus summation of X into bracket squared, then multiply. E dot ni multiplication, ndio usi confuse na X, so ufanye the same thing huku chini for Y. So N summation of Y squared minus, ni formula unaweza kumbuka tu, whatever you have done to X in the first part, fanyia pia Y, and then uaverage hizo mbili, inaitwa geometric mean. Hizo ndo moments, but we don't need to go there. We are not deriving the formula. Wewe make sure ukiambiwa apply formula and apply it. So ni N summation of X Y, alafu chukua summation of X multiplied summation of Y. Huku chini kwanza summation of X squared, N summation of X squared, alafu hiyo X we square times the same thing for Y. Multiply the two, put them under a root, then you are there. You get the square root of that. During your protest in Gen Z, I saw something very interesting. I saw something like this. Somebody who can chart what that means. I'm waiting. It's a light moment. Thank you. Thank you, Kibibi. I'm not going to say it. If you want to see what it is, you can. We are not in politics, but you can go to charts kama hujaiona kitu kama hiyo. Thank you. No, now you are aware. Yusuf, thank you. So let's proceed. So that is the square root. You get the square root of everything there in brackets, and then you proceed. So I proceed. E value, by the nani Carl Pearson anasema that this value kuinterpret ni rahisi. The answer you will get from this formula will always be between plus, this is how we interpret it. Value itakuwa always between plus and minus 1. Don't write tandika. It will always, hii answer utapata from this R will always be between plus and minus 1. Therefore, that's how you'll interpret it. Easy pita 1 answer utapata from this, and short plus or minus 1 means the farthest this value can go ni positive 1. This answer can either be negative 1 mpaka positive 1. Easy toka hapo, inaweza kuwa between 0, ikienda sana positive 1, ikishuka sana negative 1. It's between 0 and 1, either positive 1 or negative 1. And therefore, that's how you interpret. Usitupatie answer hata wewe mwenyewe ukikuwa kwa exam room. If you're in the exam room and you get an answer more than 1, ukisha calculate kitu, don't even waste time bringing it for marking. It is wrong. Usitupatie answer kama 6 ama umepata 167 as the value of that. Hizi fika huko. Hiyo tu jua uko wrong, usilete for marking. The answer can be 0 to positive 1, 0 to negative 1. That is how this works. So say that, alafu nikuambie vile una interpret. How does this interpretation, how does this R fall in any one of these categories? So say that, usiandike first, say it first that the value of R Very important. This is how you interpret it. Paragraph, the value of R will always be between, andika hivyo vile nimeandika, andika tu, will always be between plus and minus 1. Between plus minus 1, and interpreted as follows. And interpreted as follows. And interpreted as follows. And interpreted as follows. A, if R is equals to 0, if R is equals to 0, there is no correlation. There is no correlation between X and Y. There is no correlation between X and Y. There is no correlation between X and Y. B, if R is equals to +1 or -1, +1 or -1. Ni self-explaining. I don't need to ask you what this will mean. You answer tu utapata, you get your comment. This is a better way of, instead of kutumia macho, Carl or Pearson ameshatufanyia kazi, imekuwa rahisi. So +1 or -1, you just pick the values there and you say what it is. If R is equals to +1 or -1, there is perfect positive. There is perfect positive or perfect negative correlation. There is perfect positive or perfect negative correlation. Perfect positive or perfect negative correlation. C, if R, so not if, if ni sema, wachana na if, say, the closer, next number C, the closer R is to +1 or -1, the closer R is to +1 or -1, the higher the degree. The higher the degree of positive or negative correlation. The higher the degree of positive or negative correlation. And the D, so in short, ukiona value by the ishapita 2.5 iko huko juu, if your R will be more than 0.5, maybe upate 0.6, 0.8, ambia to examiner there is a high degree of positive correlation. Ikikuwa +1, you now know. Then the opposite is also true. Number D, the closer R is to 0. The closer R is to 0, the lower the degree of positive or negative correlation. The lower the degree of positive or negative correlation. Simple as that. So this is a more hygienic way ya kutafuta correlation, and whether it is strong, perfect, low, no correlation, you just get them from that, and that is it. It's much better than using your observation or your eyes. Illustration, can you subject this data to that formula to the kind of correlation itarudisha? Illustration. The following relates to advertising expenditure and sales of a firm over a period of 8 months. Just offered something just to show correlation. Required. Calculate and comment on Pearson's correlation coefficient. Haraka haraka, uko na formula now, you know how to get the summations. Andika tu formulas alafu nikuje nipate umenipatia answer. The answer is going to come from this formula. Okay, so we can just discuss what you need. X uta add mali, summation of x, you know, uta add column. Mali inataka summation of y, uta add hii. Mali itaitisha xy, yes, unaona kuna xy. Tulisema hii summation ukiona inamaanisha there should be a column called xy, kama una create, uko na x uko na y, sasa hii ni 2000, Teka hapo 2000. Huku chini inaenda summation of y equals squared, uko na y uta square. Y squared hauna, it needs to be added, so you create it. 200 times 200 is 40,000. Unaendelea hivyo, uta add your column. Summation of x uko nayo tayari is square, hapa unataka x squared, so finally utaka x squared. 10 times 10 is 100. Endelea, find hizo summations, peleka kwa formula, everybody knows how to substitute, alafu tupatie the answer. 2 minutes nifanye hiyo kazi, tuende kwa hiyo ingine. There is another person who has also given us a formula, lazima nikuache kama uko nayo. Okay, so we give me the data. What is the summation of x? E total x. What are you getting?
188.
188.
Yes.
What about summation of y?
2380.
xy?
6590.
5590.
6590.
And y squared?
740,200.
740,200. X squared?
5142.
Then the rest is just substituting. N is always the number of items you are dealing with. So sample size, 8 years. So to 8 months, so N is 8. You just say times summation of xy, which is 60, 590, minus summation of x, which is 188, times summation of y, which is 2380, all over the square root of 8 times summation of x squared is 5142, minus summation of x is 188 squared. Whatever you will get there, you multiply with an equivalent for y, which is 8 times 740, 200, minus y, 2380, if it is squared. Answer, just give me the answer. I'm sure you can all play with that mathematics. Anybody who has the value of r? A number between 0 and 1, either positive or negative.
0.966.
966. It's almost perfect. Your comment for this, you just say, therefore, you'll always be asked to comment. So say therefore there is, kama ijaguza 1, sema tu, ukitaka kusamata very high, there is a very high degree of positive correlation. Meaning an increase in advertising, there is a very high degree of positive correlation. Meaning an increase in advertising expenditure, will most likely be accompanied by an increase. Will most likely be accompanied by an increase in sales. By an increase in sales. Okay, so that is Carl Pearson giving us his considered formula. You can work with that formula. Kuna haja nyingine, you go and look for the past papers over the weekend, utapata zingine. If you want more questions for practice, there are so many. But let's go and introduce the third person. At least that is now a better way. We don't need to worry about the subjectivity. So kama hakuna, itajua tu hakuna. Kama ni high, like in this case, itajua ni high. If it were negative, itakuwa metu pia ni negative. But even the observation, if you look at this, unaona tu as sales increase, as advertising, ukispend 10, unapata 200. Ukispend 13, inaongezeka. Ukispend 30, it's generally has been increasing. So we agree with the assessment from the formula. But there are other formulas. Kuna mtu anaitwa Spearman, Charles Spearman. Tuite tu Spearman's rank correlation coefficient. Ndio tumdifferentiate na ule huyu tutampatia capital R. Spearman's rank correlation coefficient. So yeye anasema tu rank data alafu anakupatia formula fulani, interpretation yake ni the same way, eh? So can we just do at least 2 examples before we end it today? Say, Spearman has provided a formula that makes use of ranks. And not actual values. That makes use of ranks and not actual values. In generating the correlation coefficient. In generating the correlation coefficient. Nika the formula yake anasema tu ni 1 minus 6 summation of d squared over n cubed minus n. Over n cubed minus n, where d is just a deviation of the difference in ranks. So you have to rank, maybe you know how to rank. Ukipewa marks as students, unasema who is number 1, who is number last. So kwa letter X, pick rank the values I'll give you from the highest to the shortest. Yeah, Y, rank them to the highest to the shortest, and then apply this formula. Get the difference between the ranks, and you are sorted. N is just the sample size. 6 summation of d squared over n cubed minus n, 1 minus that. And note, a very important thing, E formula, a common mistake some students do, E formula is 1 minus 6 summation of d squared, okay, over n. It's not this. These are not the same thing. Kiandika hivyo utapata wrong. It is 1 minus this fraction. Hii ni fraction. Una solve hii, alafu ndio unakuja una subtract. Sema 1 minus this, hiyo itakuwa unafanya something different. So 1 inangojea ufanye hii fraction, alafu ipatie subtract, and then you will see whether the balance is negative or positive. So note that. But then andika to that, how do you interpret it the same way as ile ya kwanza. Sema the value of r, capital R, the value of r will also always be between plus minus 1. Between plus minus 1 and interpreted in a similar manner as Pearson's coefficient. Example. So let's look at example 1 where ranks, examiners are swali in 2 ways. He could either generate the ranks for you, so when you apply to formula, ama example 2 tutakufikia before we leave, mahali where we mwenyewe you might have to generate your own ranks. So if he has already given you ranks, so same example 1 where ranks are provided. Hapa una kazi, we subtract hizo ranks, enda kwa formula, and you will get your answer. So where ranks are provided, say example, ten employees were ranked by 2 managers. 10 employees were ranked by 2 managers in order of their potential to eventually become top managers. In order of their potential to eventually become top managers. So put them so kuna 10 employees, unapatia manager 1 umwambie, tell us who do you think between A to J who is the most ranking in terms of one day kuchukua nafasi yako as a manager. So this manager should say the same language. It's the same employees, same company. So ukipatia manager 1 na manager 2, if A is poor, if A akikuwa ranked 10, B pia inafaa muone tu kama 10. But the moment wanaanza sasa tu anasema hivi na anasema hivi, then unaanza kupata kuna issues. So let's assume, I'm just getting numbers, formulate atuambia the kind of ikikuwa negative inamaanisha huyu akikurank highly, huyu anakurank low. Hiyo ni mbaya. Tuambia, we can tell those managers, can you go and agree? Why are you giving us a negative correlation? Ikikuwa positive inamaanisha they are all moving in the same direction. Huyu akisema high, huyu pia anasema high. That's what we want. But now let's say huyu maybe our rank 10, manager 1, 9, 7, 6, 5, 4. So suppose that is the way the manager tumetumia maybe list ya manager 1. Tukipatia the same employees manager 2, I'm trying to create a negative correlation. It might not be perfect, but then suppose huyu akwe number 2, huyu angaliwe kama number 4, huyu ndiye akwe number 3, huyu ndiye aonekane kama number 1. You can see some element of conflict. Huyu akwe number 10. Huyu akwe number 9. Number 8, 6, 5. Gani hakuna? 1, 2, 3, 4, 5, 6, 7. Just trying to create some crisis hapo. It might not be perfect, wengine hawajaachwa mbali sana, lakini ukiangalia unaona hapa kuna shida. Ule mtu kama ni kupewa kazi, ule mtu manager 1 angempatia kazi, 2 angempatia. You number 1 kwa manager 1 is J. But J kwa manager 2 is number 7. Kuna issue R itatuambia that hata kama kuna some wale maybe wako almost kupatikana the same, kuna wengine kama wako close like na 2 and 5. But then bado kuna ka issue. Let's see what they say. Anyway, give yourself the task, sema calculate and comment. Calculate and comment on Spearman's rank coefficient. Calculate and comment on Spearman's rank coefficient. Rahisi wewe utakuja tu useme R is 1 minus 6 summation of D squared over N cubed minus N. Naisha kwa rank. Sasa wewe una kazi, utasema tu now nitafute D squared. Ongeza tu column ya D squared. What is D squared for now? It is R1 minus R2. Ndike tu hivyo squared. Short ranking ya the first one minus the ranking ya pili square. The moment unaanza ku create more space hiyo value inaanza kuwa kubwa, utapata tunaenda kwa negatives. So just take a calculator, do yours, I do mine. In rahisi, I can see it. 8 times 8 is 64. 5 times 5 is 25. Another 25. 6 times 6 is 36. 16, 16, 16, 9, 9, 36. I could be wrong. Fanya tu yako. The only thing tunambofanya ni tuadd hiyo column. All we need is to do is to add the column, and the formula takes care of the rest. What is the summation of the deviations? Squared?
252.
352.
252.
Loudly kidogo, sijakusikia vizuri. 252 ama?
Yes.
Okay. Yeah, so we take it to the formula. R will be equals to what? 1 minus 6 times 252 divided by, kuna 10 employees, so that is 1,000 minus 10. Then you just finish it. 252 times 6, alafu divide by 990, subtract 1. Give me the last final answer. What is the value of R?
Negative 0.527.
Negative 0.527, hiyo kitu kishaguza tu 5.5, sema high, The moment imeguza 5, that is a high degree. You can see it is not perfect, but kuna some average amount by which you might not trust these people. Shakwa 0.5, we just say, so you'll always be asked to comment. So sema, therefore, there is a high degree of negative correlation. There is a high degree of negative correlation. An employee who is ranked high by one manager, an employee who's ranked high by one manager will most likely be ranked low by the other. Will most likely be ranked low by the other. You can see it there. Kishapita 0.5, hawa katikati maybe wanaweza kuwa fair, lakini now sisi hatuko happy, you just leave it like that. Example 2, be able to generate your own rankings. Kabla tuende, tumalize na hii. What if we have not been given rankings? Where actual values, where actual values and not ranks are given. Where actual values and not ranks are given. That means I can ask you to generate your own ranks. Kama uoni ranks, ranking ni either ascending or descending order, choose one. If I give you exams za QA alafu ni class nyingine nipatane za ICT, I might want to rank nione between ICT na QA, what is the kind of correlation in your performance? Ule mtu akupoa kwa QA, is he also good in ICT? Or can we say it is vice versa? When you are good in ICT, you're not, or economics. It's something like that. We might want to see that. I'll just give you the tests. Alafu niseme who is number one to who is number last. In the ICT, at the same people, are you still number one in the other one? Generate your own ranks if they are not given. Example, so say 10 candidates for a clerical job. 10 candidates for a clerical job were subjected to two tests. And performance were as follows. So again, to assume kuna ka preliminary tests na kuna ka final. You want to be a clerk, unaweza pigishwa the first preliminary test, the final. Then these are the performances. Cut to 80, they are already in percentages. 80. Mechange moja hapo ni from 75 to 78. Okay. So suppose umepatiwa, you want to find the best candidate, you would wish hii kitu iko na positive correlation. Kama ulinifanyia vizuri kwa the preliminary, so that I might even decide not to use the final one. I want to go with some confidence that hata kama ningekupatia pili bado ungefanya tu vizuri. There should be some nice positive correlation. I don't want mtu alikuwa na 100 kwa preliminary akikuwa final anapata 20. That will be a very chaotic scene. So I've tried to create a positive one, though not perfect, but unaweza ona number last kwa preliminary alikuwa na ngapi? 30. Huyo number last akipa final akona 40. Bado huyu ni mtu tu, unajua hata nikimrusha nje I'll be having confidence. Number one kwa preliminary alikuwa na 90. Akapewa final akapata 78. So he didn't do very well, but still I am happy with the 78. So I could say that that is somebody who I would want to give the job. So any of these tests that were, if they were to be used to give the right person the job, ingekuwa tu sawa. Hata nikitumia za final, number one kwa final akona 8, preliminary akona 70, not bad. So these are reliable, not perfect, lakini R itatuambia. So do the task, jiambie hiyo swali and then uanze hiyo kazi. Say calculate and comment. Calculate and comment on the rank correlation coefficient. On the rank correlation coefficient. So kazi yako ni of course hizi ni test, define number one, zirank wewe mwenyewe. Rank ukishafanya hivyo, you will be in the same place as you are in, alafu nimalizie ukuja hapo seme R is equals to 1 minus 6 summation of D squared over N cubed minus N. 2 minutes. Just hizo missing blanks na kuja tu kuzichukua alafu uende class. Fill in those values for me. Rank the way you would rank with any exam. Who is number one, who is number last? Of course, 90 is number one. 20 is number last. It's an exam. Yeah, I'm sure you are done. Can compare notes. So number one kwa preliminary looks like F. So F is number one. Alafu there is an 80. Would be wrong, utanisaidia. Number two. Just somebody, haraka tu. A is number two, eh? B is number what? Somebody who can speak haraka tuziandike. B is number what?
4.
4. Then C?
8.
8. Next?
6.
Next?
3.
Next, niko na 1 already. So after 1, what do we have?
10.
Next?
9. 5. 7.
7. I hope everybody akona hiyo combination. Yeah, ranks. Then R2, what is A numbered?
3.
3.
6.
6.
5.
5.
8.
8.
1.
1.
2.
2.
9.
9.
10.
10.
7.
7.
4.
4, eh? So hata ukiangalia tu na macho, I'm sure you would see that yes, haiko perfect, lakini at least haiko skewed sana to one side, and against the other. If you are good, chance inakatuni kama uko poa pia side nyingine. So I'm expecting again something above 0.5 for this one. So 1 minus, you have done B squared, I'm sure. What is the summation of this squared? Nipatie final answer huku chini. Total?
38.
38, eh? Nishaanza, acha tu nimalize. Kitu kama hiyo, eh? So unaona zikireduce sasa value of course itakuwa una subtract 1 minus a very small digit, itakuwa positive. So 6 times 38 again divided by 990, 1000 minus 10, eh? What is the value of R? R? Anybody amepata R?
0.7.
7?
7-0.
0.7, eh? So then you can see that is quite high. You make your comment, then we stop it there. Just say something like there's a high degree of positive correlation. There is a high degree of positive correlation. A candidate scoring high in the preliminary test. A candidate scoring high in the preliminary test will most likely go to score high. Will most likely go to score high in the final test. The final test. Thank you. Can have a nice weekend. Put a subheading for Tuesday. Tied rankings still there. What would we do kama watu wawili wameshare the same mark, eh? So put that, tuanzie hapo as we remind ourselves maybe how we have done it. Then tuendelee na regression.